let's talk about the kidneys. The kidneys are going to be made out of, all right, externally, gross anatomy-wise, you have an external sheathing right here of the kidney. We call the renal capsule, right? Now, the kidneys are divided into two regions. The cortex, that's external, all the way out here, all the way around, that's a cortex. And then you see an inner area all the way around, that is called the renal medulla. The renal medulla is going to be divided into little triangles that we call renal pyramids. So what we see in this model is we're going to take one renal pyramid and everything that's connected to, and then blow it up here. And then we're going to take one of the renal pyramids, and at this point right here, we're going to blow it up and take a look at greater detail over here. All right, so let's take a look at the very first aspect right here. So you have the pyramids, and the pyramids contains the functional cells of the kidneys. The functional unit is called nephron. So unlike like a liver, the nephron is not just one cell. It's going to be a combination of different cells that work together to filter, secrete, and reabsorb. So what we can see is that in the nephron, the pyramids are made out of these nephron cells, right, or nephrons that are made from different cells. And the main job, again, is to filter, then secrete, and then reabsorb. Right? In order to filter, you need blood supply. So you're going to have the renal artery bringing that blood into the kidney. Right? The area where all of these vessels enter and exit is called the hilum of the kidney. Right? As you go into the renal artery splits into a few segmental arteries. So there's one segmental artery, here's another, here's another. The segmental arteries are also going to split. As it splits into arteries that are now going to be found between the pyramids. We call it the interlobar arteries. So here's one interlobar, here's another, here's another, here's another, here's another. The interlobar arteries then are going to split and form what we call arcuate arteries. The arcuate arteries are going to follow, and they're going to be found at the junction between the cortex and the medulla. So these right here are all your arcuate arteries. The arcuate arteries then are going to give rise to many arteries that radiate out through the cortex. This is our cortical radiate arteries right here. The cortical radiate arteries then are going to have arterioles that come out. The arterioles that come out will go into these tiny little white globes that we call the renal corpuscle. These tiny globes then, are going to allow us to filter and then hopefully reabsorb. Now, on this model you can see pretty good artery supply, but this model you can really see it well. You can see the interlobar between the lobes turning into the arcuate, number 7, and lots of cortical radiate arteries radiating out of the arcuate. You'll also see the afferent arteriole coming out. And it's these afferent arterioles that we're going to use to filter. As we filter, fluid and salts go into the capsule, then goes into a system of tubules, which allows us to reabsorb any of the water and the salts. Whatever goes stays in, and we don't get reabsorption. Whatever stays and is not reabsorbed will be found in the urine. Now, what we're going to see is that you have lots of collecting ducts. All these white streaks right here are all collecting ducts. Lots of collecting ducts are going to be bringing the filtrate. That's the name of the urine before it enters and exits a kidney. As we filter it and it goes down the tubules, goes down the collecting duct, is still called filtrate. As the filtrate goes down the collecting duct and into these larger funnels, as the filtrate goes down, it empties into the minor calyx. So you see minor calyx here, minor calyx here, minor calyx, minor calyx, minor calyx. The minor calyx has openings for the collecting ducts. The area where all the collecting duct opens is called the renal papilla. So here's one renal papilla, and if I can see it right here, if you take a look on this side, you can see half of a renal papilla. And it should look very similar to this. So the renal papilla allows you to drain all that fluid through. As that filtrate goes into the renal papilla, it goes into the minor calyx. At this point, there's no more reabsorption. Now we can call it urine. Multiple minor calyces forms a major calyx, and multiple major calyces forms the renal pelvis. The renal pelvis then exits out as a ureter. Right? Now, the ureter, right, exits out and it goes and empties into the bladder. Now, when you take a look at this model, understand that, right, in this model, you'll see, right, the renal corpuscle. And the renal corpuscle is going to be blown up right here, right? And it consists of the corpuscle consists of your capsule, Bowman's capsule, as well as a blood vessel found inside. The blood vessel is going to be nice and convoluted, so then you have more surface area for filtration. The blood vessel here is called the glomerulus. Now the glomerulus contains our capillaries that are fenestrated. So fenestrated capillaries have a little bit of opening inside the cells, got little windows, right? And it could allow a little bit of protein to go through. Again, we should never see protein, definitely should never see red and white blood cells in our urine. So how do we make sure that small proteins, medium, large proteins, red blood cells, white blood cells don't get through? Is by having the blood, all right, the glomerulus right here, having cells line it, closing those fenestrae. The cells that we see here, all these black dots, right, those are called podocytes. The podocytes wrap itself around the glomerulus, allowing only water, salt, a little bit of glucose to then be funneled into the proximal convoluted tubule. Now, the blood vessel that allows blood to enter into the glomerulus is number 6. This is the afferent arteriole. The blood that exits is going to have less water, less salt, less glucose, so it comes out and it's number 7, the efferent arteriole. And usually the efferent arteriole looks a little bit smaller than the afferent. As that fluid that we just filtered moves down, right, it gets funneled into the very start of our nephron system. This is what we call the proximal convoluted tubule, and the proximal convoluted tubule is also this area right here, and we're going to see lots and lots of reabsorption of salts, all reabsorption of glucose, and lots of reabsorption of water occurring here in the proximal convoluted tubule. As it exits, right, the filtrate goes through, and if you look at the efferent arteriole, some of the efferent arteriole continues out, and it follows, right, and it follows the proximal convoluted tubule. So these blood vessels right here are called the peritubular capillaries. In order to reabsorb the nutrients we just filtered, right, we need to take it out and we need to bring it into the bloodstream. So you need these blood vessels to be very close to the distal convoluted tubule. And we do have blood vessels that are very close, the peritubular capillaries. Right, as the fluid goes down, the filtrate goes down the descending limb. It makes a U-turn, goes up the ascending limb, and goes into the distal convoluted tubule, where then it empties into the collecting duct. One collecting duct receives many distal convoluted tubules. Again, the longer the loop, the more we can concentrate urine. Now again, right, we're going to see that on the descending limb, water exits. As it exits, we got to reabsorb it, and this is the blood vessels that allows us to reabsorb it. This is a vasa recta. All right, on the ascending limb, you're going to reabsorb salts, right? As you reabsorb salts, the salts are going to be reabsorbed and moved out of the tubules and go into the vasa recta as well. All right, the vasa recta is the blood vessel that follows the loop. Is part of what we call the counter current exchange, which we'll talk about later. As the ascending limb moves up, it kind of loops back around. It loops back around and makes contact with your afferent arteriole. We'll talk about why that's important later on, but just understand it loops back around. As it loops back around, it makes contact with the afferent arteriole, which is what we see here, right? You see this is your distal convoluted tubule, and it wraps around and makes contact with your afferent arteriole. These are the cells of the macula densa, and then you see cells lining the afferent arteriole. We call them juxtaglomerular cells. Right? The combination of these two allow us to have negative feedback, so then we don't overproduce dilute urine. Now, all right, as we move back here, all right, you'll notice as well that many, all right, collecting ducts empty into a minor calyx, which then empties into the major. Now, good news about the blood supply here, all right, we talked about the cortical radiate artery. The blood supply back has the same exact name: cortical radiate vein, arcuate vein, all right, interlobar vein, segmental vein, renal vein. Perfect.